This presentation was made during my internship at Inria, Rennes in August 2021. Feel free to ask questions or react in the comments or by mail. The goal here is to implement cloud-native practices, set up a DevOps application lifecycle, particularly deploy, operate, and monitor in this internship. And so let's go. Talking about me, I'm in fourth year equivalent of Master 1 at ESIR, here at the university, and I study information systems. I started with a Minecraft server when I was 12 years old. I wanted to make a Minecraft multiplayer server with friends, and I started to invite more and more people. And 2 years later, it ended up at the first position of friend server ranking for 6 consecutive months. So I needed a website, a shop, and unique features like Java plugins, etc. I started to learn it, and it started my passion for programming and servers. And then coming at the university, I started working on NoxuNote, which was made for me at the beginning, and I started to share the software to other people. So today I'm interested on ops and cloud, but before I started development processes. So talking about DevOps and cloud, here is the plan for the presentation. First, I will present to you NoxuNote and the technical context. Secondly, I will present to you what is an IAP and how it solves problems in our context. Then in the third part, how did I implement the DevOps lifecycle, in my application. And then moving to Kubernetes and deploying in production with Google Cloud. And the last part will be an opening on what there will be next in my internship. So first, technical context. So NoxuNote is the libre note-taking app for students. There are 2 main versions. Here you can see the beta 1, which is actually on the website, noxunote.fr. The first version is the desktop app only. You can work offline, no internet connection. You save notes on your disk. But I have learned Node.js with this first version, so I did some back practices, anti-patterns, and today the beta 1 is hard to scale and develop. So after many experiences, internships, particularly with Angular and Spring and things like that, I have learned more industrial methods, frameworks, so I decided to rework the application from scratch. So here you can see the beta 2, which is a more cloud approach and a web app. On the right, you have a screenshot of the beta 1 version. You can download and test it if you want. So the beta 2 new features are the app is usable in a browser. You can save your notes online with an account and access them everywhere, just like in Google Docs, for example. And the website, once you've reached the website once, you can go back even if you don't have an internet connection using progressive web apps. And you can create notes, save them, and they will be saved in the browser's local storage, and they will automatically be synchronized when you get back online. And there is also the desktop app, which brings you the ability to save notes on disk also if you want not to work on a cloud platform. So those new challenges bring new architecture, of course. So there is the new cloud of NoxuNote. So you as a user use NoxuNote on the desktop or browser version, and this software accesses and saves notes in the cloud using this website. So the new features are we have to manage personal accounts, provide online note storage, heavy file storage like image or diagrams. They need to be saved in a separate part because they are heavy, and the cost associated is not the same, and provide high security and backup. And in this internship, I focused on cloud deployment, high availability with Kubernetes and monitoring. So what is behind the cloud? Microservices is an architectural approach to develop an application as a collection of small services. Each service implements small business capabilities. They run on their own process and they communicate together via HTTP APIs or messaging. So this is the way I choose to implement cloud native practices and therefore exploit the advantages of the cloud computing delivery model. And because services are small, they focus on single responsibility and using a service dedicated to authorization, authentication, and identifying the user will greatly simplify the development process and testing microservices. So one way to solve this problem is using an IAP. Benoit, you sent a message. Okay, I will take a look after. Thank you. You can set up an IAP. It stands for Identity Access Proxy or Identity Aware Proxy. So it's a gateway or a reverse proxy responsible of allowing, denying, redirecting, and identifying all the incoming traffic and adding the header that identifies the user. In doing so, microservices can blindly trust incoming requests from the IAP and know which user is behind the request in a stateless way. So Google has an IAP module, Amazon Web Services also, and Azure. So looking at open source, cloud native, modulable, and very configurable solutions, you will find things like Ori. Ori implements every feature in a separate microservices. For example, IAPs in a microservice, user management, login UI, OpenID registration for handling GitHub login, Google or Facebook login. And it's a pretty good solution. You will also find alternatives like Keycloak. I don't know if you've heard about that. So to implement this in our application, on the left, you can see we use Housekeeper as an implementation of the IAP. It will be the gateway to access microservices like Kratos. Kratos is the public REST API for login, account creation, or account management. So everything is already done in the Ori pre-configured project. So you just have to plug your business logic, and it's ready. Because Housekeeper is a zero trust proxy, it means it will block all incoming requests on your services. So you need to configure every traffic rule by hand. So let's configure the route for accessing Ori Kratos API. So Ori microservices work with simple and declarative YAML configuration files. So for example, here we declare a first rule, meaning if the user matches this blob for URL, we redirect the request on this microservices. So here you have a DNS name because we're working in a Kubernetes context. I will present you Kubernetes after. And each service is reachable through a DNS entry. And this is also available when you're using Docker networks. And for this traffic rule, we have no authorization, no authentication, and no mutators. This means we can test by a simple curl request that our service responds correctly. So people will not create and login through their account using a curl request, of course, or Postman. They will need an NOS interface. So we will add a /auth endpoint that will redirect to a static web server, which serves a landing page to connect, register, or login. So it's the same. We had a traffic rule matching cloud.noxunote.fr/error recovery verify on auth, and it redirects to the microservice. Here you can see what the interface looks like. It's the default interface of Ori. We've made some customizations for matching the theme of NoxuNote. Okay, so now everything about user login is configured. We have to implement our business logic. So I've made a microservice named MyNotes API. It's the main REST API for creating, reading, editing, and deleting notes. And it will be reachable through /mynotes endpoint. So it's again the same. We will add two endpoints. So the first endpoint is the public ones. So it's about getting the documentation, the open API documentation of the MyNotes API. And that's it. And the protected endpoints are about creating notes, reading your notes, etc. So we need to configure two rules. So I have a question for you. For this request here, what is the first rule matching? Is the second rule matching? What is your opinion? That's it, Ternava. The first rule will be matched. So we will have a response from the microservice. And for the second curl request, I think you've guessed, it's the second rule, because you have /notes here, and you find the /notes here. But the second request will be blocked by the proxy, and we can test this. For example, here with the first request, we have a good result, but the microservice is answering a redirection. But that's normal. That's the normal behavior of MyNotes API. And with the second rule here, we can see that without any authentication, we have unauthorized response. And if you are doing the request using a web browser, we can emulate this including headers in your request. You can see that we have a redirection to /o/login. And that's the behavior we've configured here if there is an error. Okay, so now our IAP is configured and everything is good. Let's talk about the DevOps lifecycle. So DevOps is the set of philosophies, practices, and tools to deliver products at high velocity. It enables teams to continuously deliver tested, versioned, and monitor software. And with short cycles, DevOps teams can access markets faster and quickly adapt to new needs. So let's have a look on steps from test to monitoring. So testing MyNotes API will be easy because in an IAP architecture, microservices blindly trust all incoming requests on all endpoints. So we only have to isolate MyNotes API and run raw request on the all endpoints we want. So here we are using Cypress for integration testing. Here you can see some tests. So I send a post request to a secured endpoint. Do you remember? It's the second rule. And we are also injecting our own user ID, which is normally injected by the IAP proxy. So we can mock every user we want on every endpoint. And then you have the tests. So GitHub workflows are YAML files that describe a pipeline of things to do for building, testing, and deploying software on a push or a pull request. So we can use plugin made by community to simplify our pipeline. For example, here we set up a simple PostgreSQL server, and we run our Node.js application and the test suite. And GitHub Action will automatically give us a report on the test. Here you can see tests have successfully failed. Concerning the release, I actually do it by hand using Git tags and Git and Docker build, but you can those actions could be automated in GitHub Actions. The same goes for deploying application. It could be automated. And I will talk about Helm and Kubernetes later, but they are focused on those aspects. Concerning monitoring, Prometheus, we have several technical solutions. The two mains, the more famous ones are Prometheus for scrapping and plus Grafana for displaying. Prometheus is open source and free, and it has pretty good integration with Kubernetes and many other software. And there is also Datadog, but there were no many questions. We run into Prometheus for all the advantages. So Prometheus server's role is to gather all the measurements, performance metrics, time series, custom metrics, and store them in his own integrated database. And then we can exploit those results using Grafana. So let's implement this. On the left, you can see the pooling configuration from Prometheus. That's how Prometheus will gather the information from microservices. Metrics can be about running time, starting time, how many users are currently using the service. This can be anything you want. Kubernetes has also integrated metrics on CPU utilization, memory, on bandwidth, etc. But for your business logic, you'll need to add by hand the link to Prometheus. So Prometheus will automatically scrape those endpoints. And on the right, you can see we use Kubernetes ingresses that enables a direct access to Prometheus and Grafana. But the good practice is to use the IAP, and I will do it soon. So we also need to add custom business logic metrics. So there are two ways to add custom metrics. The first one is community exporters. Exporters are kind of software which provide metrics scrapping endpoints for famous software. For example, here you can see the Prometheus Postgres exporter, which enables the ability for Prometheus to scrape information from Postgres. And we can build our own queries, our own metrics here. For example, the number of NoxuNote accounts, which is a counter using a simple SQL query. And we can add as many metrics as we want. That's one way to create business logic metrics. You can also add on your microservices HTTP endpoint for scraping metrics. So on Grafana, you can see those metrics on the metrics browser and even build a custom dashboard. You can use community dashboards for famous metrics and also setting up alerts. So then how did I move to Kubernetes and Google Cloud? Kubernetes is a system for running and coordinating containerized applications. It works with a cluster of nodes, and its main features are scheduling, self-healing. If a node goes out, Kubernetes master nodes will try to self-heal and move the workload on the working nodes. So there are also progressive deployments, rollback using Canary deployment, for example, and high availability with replica and auto-scaling. And Helm is the package manager for Kubernetes. You can define, install, and upgrade complex Kubernetes applications in charts. And you can use community charts and create a chart that group community charts and override the default values. And that's what we will be doing for NoxuCloud. So we create a chart. A chart is basically two files, a chart.yaml. So we describe what is our chart, so NoxuCloud, a description, version, and every other subchart we will need to use for NoxuCloud. For example, we need pgadmin for exploring our database. We need Postgre. We need MyNotes API, which is another Helm chart I have designed. Kratos, Housekeeper, and everything we want. And because those are Helm charts, they have a value inside them, but we can override those values using our values.yaml files. So for example, we can override MyNotes API default values in our values file. So to deploy this, we have to set up a virtual cluster in a dev environment. We can use Minikube, Microcavities, or Kind. There are many solutions here. But I will be using kind. So for example, with kind, you can run, for example, 4 Linux Ubuntu containers with containerd and kubelet pre-installed and already configured. So it's easy to use, and it will be ready for testing once you install kind. We've been using environment variables because depending on the environment, we have different protocol, HTTP, HTTPS, or different hostname, and we need to replace them by the one we want. So we used a small GNU, it's a GNU package. So it's in many distributions. It can replace the environment variables in the files with the one of the user logged in. So we use env subst to transform our values.yml file and pipe the output to Helm here. So Helm will have a version with patched variables. In a dev environment, you do not forget to change your etc hosts file, and then you can check your readiness with kubectl commands. To deploy on Google Cloud, there are many cloud providers that integrate a Kubernetes engine. It translates your Kubernetes app into the custom cloud resources. For example, with Google Kubernetes engine, it will automatically translate your persistent volume here for NoxuNote to Cloud Volume Services or File Store, which are Google-specific resources. So maybe I can show you a little bit. I don't know. Can someone tell me if I have enough time to show you? Maybe. So you can create your own cluster on Google Cloud. You specify the number of nodes you want, and what kind of node you want. Here we want 2 processors and 2 gigs of RAM. In order your chart to work, you have to make some small changes, like changing ingress rules. And then you can deploy in Google Cloud your Helm chart using the same command as in a development in your development environment. So here you can see the values I needed to change. So ingress rules, and remove the nginx ingress class name, so Google can provide its own ingress controller. And once our cluster is ready, we can use their UI to check readiness and also to ping the service if we want. Because for each ingress and endpoint we set up in our Helm chart, Google will dedicate an IP, and we can bind a DNS address to this IP and check and use our application in production this way. So, but in the future, in my So now our cloudification is almost complete. We can take a step back on this experiment and think about research problems. We can gather more specific data with the use case of NoxuNote, such as starting time, building time, as a function of input parameters. And I think about how those collected timings can be a part of a global knowledge database. This database could be analyzed, or we can build a deep learning model to discover some patterns between app design practices and build and starting time. So other applications timings sharing the same properties as NoxuNote could maybe be predicted. The goal is to make an IDE extension predicting lifecycle timings, and this would greatly help developers to save time and better identify caveats and even suggest how to improve them. So in the case of NoxuNote, we can ask ourselves, what other informations can we monitor, what are the properties that will affect timings and our decisions. But that will be the part of what I will be working on in the upcoming weeks. And that's all for me. Do you have questions?
Yeah, maybe we can take a few questions before switching to the next presentation.
Yes, June?
Okay. So if I understand well, what you've done is basically build the whole environment for your NoxuNote cloud app to be able to be usable in a cloud, but also for all the continuous integration process, and then also to have to collect all the information about building the application and so on and so on, to then create a database with all the information. The end goal is in fact to build that big database with all information. Is that your end goal?
So your first point is right. I've created the whole DevOps environment and Kubernetes chart and deployed it on Google for the application. But I will more say lifecycle monitoring and database and the extension is more something optional that goes. We can profit the use case
Okay.
of NoxuNote to think about other research problems, and that's more coming from my internship, and it is not a dependency from for NoxuNote. It's an external thing.
Okay, so what you can say is, okay, those types of technologies or tools are the best to develop and deploy a cloud application. That
Probably not the
environment,
best, but there are
okay,
many
is a good
solutions.
one
But
to do that. Okay,
the one I choose.
okay, that's good for me.
Thank you.
Thank you very much, Leo, for the presentation. It was a very nice presentation. I was just wondering, you said at the very beginning that the first version was hard to maintain and to involve. My question would be, are you now convinced that the new software architecture is better for this? And if so, of course, why?
Why I don't understand your question. Why this architecture is the best for my needs?
I'm not saying the best, but at least why it should be better than the first one. You started your presentation by saying that the first initial architecture was
Yes.
hard to maintain and evolve. I'm
Yes.
quoting you word by word. And now you change the software architecture, moving to a cloud native architecture.
Yes.
And my question is it now better?
No, I can't see the final results because it's in development. But I'm convinced with what I have learned at the university that those processes will bring me high quality results and scalability, and the modularity is a good practice. I can replace every microservice I want. I already have some benefits, like if I have an issue, I can, with my monitoring solutions, I can quickly see where is the problem, and I can bring alerts, and I'm pretty sure that will soon give me great advantages.
Thank you very much for your confidence on what you're learning at the university. So I think, of course, it's clearly better for many advantages, but maybe we should be leveraging on your experience. I'm just wondering if we should not define clearly some metrics that allow us to compare the two architecture and then report on this. I see Stephanie connected, so maybe
Yes.
it's a short-term perspective
Yes.
before going further with collecting the data and trying to make some recommendation. Maybe the first short-term perspective would be this: which kind of metrics would be relevant for comparing them, and can we report on a comparison of those? Because now we have the two. So that's a very nice material that we have at hand. So we should use this, I think.
Yeah, thank you. Taking this in consideration for upcoming weeks.